Before we go any further, I'd like to show you a mathematical trick that's going to be very helpful to us as we go on with this smartphone calculation. A very common situation, which we're going to see in the next video, is when you have a very long, thin triangle. You know the angle in here, call it theta. You know the length, let's call it d. And you want to know how long the far end is. Or maybe you know d and r and you want to work out theta, or theta and r and you want to work out d. Some combination of these things. Now this is a very common situation, and it's one that's very easy to get bogged down in. Why? Because it's not quite a well-posed problem. What we mean here could mean a bunch of different things. It could be that our triangle actually goes like that, then has a right angle there. And that's theta in here and d down there. Now in that case, tan theta is opposite over adjacent, so tan theta equals r over d. So we could write that r equals d tan theta. But that's one possibility, but it could be that the right angle is at the top. So that's a right angle. D as before, theta and r. In that case, sine theta equals r over d, because d is now the hypotenuse. So r equals d sine theta. Or it could be that this is like the segment of a pie, and that's actually a circle, an arc of a circle over there. So theta, in this case, both this length and that length will be d, and r will no longer be a straight line, but a small arc of a circle. Now in this case, the way you can work out what r is work out what fraction of the total circle it is. If you do a circle all the way around, the entire circle is going to be 2 pi d circumference. But this is not all the circle, it's a fraction theta over 360 of it, times theta over 360 if it's in degrees. But it turns out this comes out more simply if you measure theta in radians. And if you measure it in radians, it turns out that r is just d times theta. The reason is that the circumference for the total angle all the way around a circle in radians is just 2 pi, so the 2 pi's cancel top and bottom. Or you could try something else, like you could assume that there's actually a right angle in the middle. And so this is d, that's d, this is a bit less than d, you've got r there, and that's theta over 2 here, and theta over 2 there. And you get some horrible tricky thing in there. So there's a lot of possible answers here. But if you look at all these triangles, you'll see that by and large that length and this length and this length and that length all look pretty much the same. It doesn't seem to make very much difference. And if you actually try plugging into a calculator, you'll find that for small angles, tan theta and sine theta and theta, as long as it's measured in radians, are all extremely close to each other. So this is a small angle approximation. For small angles, roughly theta less than 10 degrees, sine theta is about equal to tan theta is about equal to theta in radians. And for this situation here, r is just d theta. Again, if theta is measured in radians. And that's what we're going to need to use going forward.